Hey guys, this is 2.7 and 9.1. We're going to go over linear inequalities, how to solve one like we were solving linear equations. So solving for a variable, solving for x. We're also going to talk about how to write them as on a number line and how to write them in interval notation when you just have something like x is less than -3. Okay, so we're going to go over what all of that means. And here are the notes we're looking at. So solving inequalities. What is the difference between an equation and an inequality? An equation has an equal sign. There's also expression. An expression would just be x minus 5. That's an expression because there is no equal sign. If you add the equal sign, it becomes an equation. And if instead of the equal sign, you were to put a greater than or equal to sign, or just a greater than sign, that becomes an inequality. So for an inequality, you have, sorry, I thought it was on here. You have infinite, yes, it's right here. You have infinite solutions. So if we were to say x is less than 3, that's saying every single number less than 3 is a correct answer, is one of the solutions of the inequality. Okay, so you're never making a list, you're just saying infinite solutions. There are infinite numbers that are less than the number 3 in this example. Okay, so equations contain equal signs while inequalities contain one of 4 different types. Okay, so we have the greater than symbol, the less than symbol, the greater than or equal to symbol, and the less than or equal to symbol. Those are your 4 options, okay? Solving inequalities works exactly the same as solving equations, but there are 2 very important exceptions that you cannot ignore, okay? And they are multiplication and division by a negative number, okay? So, for example, let's say I do have this x minus, or no, let's say x is less than 10. Okay, x is less than 10. If we're not even gonna do x is less than 10. Sorry, guys, I should have thought this out before I started talking. Let's say 5 is less than 10. Much easier to understand that one, right? It is true. 5 is less than 10. If I take 5 and 10 and I multiply them both by 2, then I have 5 times 2 is 10 is less than 20, right? Okay. What if I divide them both by 5? 10 divided by 5 is 2, is less than 20 divided by 5 is 4. 2 is less than 4. That's still true, right? I can multiply, I can divide, I can add. 8 is less than 10. It's still going to be true, right? However, if I multiply by a negative, so I'm taking a negative number and I'm multiplying it by both sides, just like we multiplied by a positive, just like we divided by a positive, just like we added, okay? -2 times 8 is a -16, less than 10 times -2 is -20. Now, I know it's hard to conceptualize the negative numbers, but if you were to look at a number line, -16 is here and -20 is here. So -20 is less than -16. It's not greater than. So the sign no longer applies correctly to this equation because we multiplied by a negative. Okay, so when you multiply by a negative number, you just multiply the regular way, but you have to switch this sign. So this sign is now the opposite. This is the less than sign. It becomes the greater than sign, and it will always be true. 10 times -2 is -20. Okay, let's try it again. So now if I divide by -4. Okay, again, I'm dividing by a negative, just like up here, I was multiplying by a negative, so I need to flip the sign. -16 divided by -4, a negative divided by a negative is a positive. 16 divided by 4 is 4. Negative 20 divided by negative 4 is 5. 4 is less than 5. So it's true when I switch it, okay? And just because we are talking about negatives, you can subtract, right? Or add a negative number to it. You don't switch the sign. So 4 minus 3 is 1. 1 is less than 5 minus 3 is 2, okay? So it's only multiplying or dividing by a negative number that causes you to flip the sign. The sign got flipped because we divided by a negative. The sign got flipped because we multiplied by a negative. I know that was a tangent. Come back to it after we practice this a little bit if it still doesn't make sense. But when you multiply or divide both sides by a negative number, the direction of the inequality reverses. So greater than becomes less than, greater than or equal to becomes less than or equal to, okay? We just flip it. 2 is less than 3, but if you multiply both sides by negative 1, then negative 2 is greater than negative 3 because that is true according to the number line, okay? Unlike equations which only generally have one solution, x equals 3, x equals negative 4/7, inequalities have infinite solutions. So for this one, x is less than 3 means there are infinitely many numbers that x can be for this inequality to be true, okay? And to show your answer, we either graph it on the number line or use interval notation, okay? When graphing solutions on the number line, there are two main parts to pay attention to. Graphing to the left, or graphing to the right, okay? So let's look at what I mean by graph. Okay. Sorry, my screen is super small. All right, so here is Desmos. It is very important that you get comfortable with Desmos. It can help you with a lot of the exam questions, okay? If you're stuck, just type anything into Desmos, okay? So, graphing inequalities. We have been talking about, for example, x is less than 3, okay? Oh, sorry, I said less than and wrote greater than. X is less than 3. Do you see how they found 3 on that x-axis? That's the number line. They found 3, and then they said everything less than 3. So it's read forever towards infinity after negative 3. That's what they mean by x is less than 3. If we were to say x is greater than 3, it would be to the other side, right? And you can even say x plus 5 is greater than 3, and they will solve x for you. X is equal to negative 2. Okay, so that's what we mean by a number line. It's just a line with numbers on it. It's only that horizontal line. It's not the vertical line, but you can use the two-dimensional graph to graph it in Desmos. It will help you, okay? So when we're talking about to the left or to the right, this one is going to the right because it's the greater than symbol. This one's going to the left because it's the less than symbol. Make sure your variable is on the left side of your inequality if you're going to use this rule of left is to the less than is to the left and greater than is to the right. You have to make sure your variable is on the left side of the equation. Because look, if I put, so we see that it's on the left side, right? With the less than symbol. However, if I put my variable on the right side, then that rule doesn't apply because my variable is on the wrong side, because that is the same as putting it backwards. Okay, so I always make sure my variable is on the left just to avoid confusion. All right. It depends on if the variable is less than or greater than. X is less than a number. X is less than 5, and we can also write it as 5 is greater than x, but we don't like that one. That one's more confusing. It means graph to the left. Here's 5, and we're going to graph to the left. I like to think of it as this inequality symbol is also my arrow. So my arrow is going to the left, so my line is going to go to the left. My graph is going to go to the left. Good. Here we have x is greater than 4, or 4 is less than x. Again, with your variable on the left, just use that as your arrow. That's not only a greater than sign, it's an arrow for which direction to graph it. Good? All right. What symbol do you use on the numbers that form the left or right endpoints? So we're starting at 5 and we're going for infinity in the left-hand or negative direction, right? Because it is not equal to, it ends like this, okay? Just x is less than 5 means we use a parentheses, okay? X is greater than 4, also going to use a parentheses, okay? Less than or greater than, we have parentheses. Okay, what's the alternative to parentheses? That would be brackets. So if it's less than or equal to, use a bracket. If it's greater than or equal to, use a bracket, okay? We'll practice this. I know this is a whole lot of information at once. Interval notation is writing an interval based on its left and right endpoints. And the general form is you start with one of these symbols, a bracket or a parenthesis. You put the number you start with from left to right, and then you put the number you end with from left to right, and then you close it with whatever symbol it is, either a parenthesis or a bracket, okay? It's easy if you graph in a number line and then start with, and then use the number line to kind of guide how you're gonna write your interval notation, okay? Using parentheses in interval notation is for these symbols. Brackets is for these symbols, okay? The brackets mean including. To include it, okay? All right, so here we have what it might look like. We have brackets, but they're curly brackets, okay? The curly brackets are not part of the inequality. We have a curly bracket, X. This is the symbol, we say such that. So curly bracket X such that X is greater than 5, and then the bracket closes, okay? So all of them, if you'll note, have the X such that, and all of them have the curly bracket. So that's not something that you need to include in the math part. That's just how they explain or introduce it, okay? It's just math punctuation. So we have X is greater than 5. What you want to do is decide if it's the greater than symbol, that means it's going to go this way. So the greater than symbol uses this, okay? Oh no. You can tell that I like get confused by greater than and less than. The less than symbol, we're going that way, so it's going to use this symbol. All right? Greater than or equal to includes, okay? Includes, so it uses a bracket to include, and it's the line's going that way, so the bracket is going to open to the right. And then our last one, less than or equal to, uses that bracket. All right, so this is, and that's when X is on the left. So X is greater than, use that. Your variable is less than, it might not be X, it might be a different variable, uses that close parentheses. X is greater than or equal to, uses a bracket. And X is less than or equal to also uses a bracket. All right, so if you get lost, you're welcome to just make a little chart. And of course, you're welcome to use, you're also welcome to use Desmos, right? So we said x is greater than uses the parentheses. The parentheses in Desmos is represented by a dashed line, okay? But x is greater than or equal to, we'll say 7, uses a, so if it's a bracket, it's going to use a solid line. X is less than -2. Because it's less than, it uses a dotted line, and that's a parentheses, okay? And then x is less than or equal to -8. So because of the equal to, it's a solid line. So the equal to means including, okay? It includes -8, but x is only less than -2 means it doesn't include -2. X is greater than or equal to 7 means it does include the 7, so it's a solid line. X is greater than 4 does not include 4, so it's a dashed line. Okay, so greater than 4 is going to be the parentheses. It doesn't like that, right? Less than or equal to, or sorry, greater than or equal to is going to be the brackets. Less than is going to be parentheses, does not include. And then less than or equals to is going to be the bracket, does include. Which I know made all of the disappear, but that's what I mean, okay? Is it included or not included? Here, x is greater than 5. Find 5. Gosh, that's small. Here's 5, I think, right? Greater than, that means the arrow is going to go that way, just like that. Greater than sign looks like an arrow going that way, okay? So I'm going to go that way. And then do I use parentheses or a bracket? Greater than does not include 5. So to not include 5, parentheses. Good. If we included 5, it would be a bracket, and we're done. That is the graph. And then interval notation, like we said, it's easier to write interval notation after you graph it. So I'm just going to read it left to right, read my graph left to right like I am reading a book. Left to right, I encounter a parentheses. Where's the parentheses? It's at 5, and then it's going to end. Ooh, it never ends. It ends with an arrow in the positive direction. What we call that is infinity, okay? Infinity always uses parentheses, and negative infinity always uses parentheses, okay? Because remember, parentheses means does not include, brackets means includes, so you can't include infinity. Infinity isn't a specific number that can be included or excluded, so it's always does not include infinity, okay? Here we have x is less than 3. Find 3 on your graph. Maybe here. Good. Less than, that looks to me like an arrow going in that direction. Forever, okay? Because it's a less than, it does not include 3, so it's going to get a parentheses. You can also look at your cheat sheet over here, okay? How would I write it in interval notation? Read it like a book, left to right. The first thing I see is an arrow in the infinity direction, in the negative infinity direction. So I'm going to start with negative infinity. I'm going to start with negative infinity because that's an arrow going towards negative infinity. What does negative infinity use? It uses a, it does not use a bracket, it uses parentheses. Good. Then where else do I see it? Where do I see it stopping to the right? It's stopping at positive 3. And then we're going to close it with whatever bracket the graph has. Good. Here we have x is greater than or equal to -7. So find -7. Greater than -7 means every number bigger than 7, right? Forever. Every number bigger than -7 forever. It includes -7, so now we're going to do a bracket, okay? So that means, and what it means is this number is greater than or equal to this number. That means it can be -6. It can be -5. You can pick any number on a number line that is shaded, and it'll be true. 0 is greater than or equal to -7. -7 is greater than or equal to -7, right? Okay. How would I graph this? It starts with a bracket. The bracket's at -7. and then it goes forever. Good. Here I have x such that x is less than or equal to -3. -3 is here. Less than or equal to, the equal to means it's going to be a bracket. And, oops, I went the wrong way. The arrow goes this way, right? The arrow goes that way. It's every number less than -3. Good. Every number less than -3. So if I was to put it in interval notation, reading it from left to right, it starts with an arrow pointing towards -infinity, and then it ends at -3. Good. All right, here we have x such that 3 is less than x. I am going to flip it. I don't like that. I'm going to flip it to x is greater than 3. That's easier for me to read than 3 is less than x. Is it still true? Let's test it. 3 is less than, if I make x 10, that's true. 3 is less than 10. 10 is less than 3. It's still true, okay? So I just flipped everything. If you change the order, so this was at the end and now it's at the beginning, you have to flip the sign, right? 3 is less than x is greater than 3. If you read it backwards, x is greater than 3, x is greater than 3. 3 is less than x, 3 is less than x. Good? So, but now it's easy to read. So I'm going to start at 3. It's greater than 3, so it's going that way. It is not including 3, so it gets a parenthesis. When I'm reading it from left to right, we're going to start with parenthesis, 3. Goes forever. There's an arrow, so it's infinity. Infinity always has parentheses. Good. All right, now we have compound inequalities, which means that we are not graphing necessarily towards infinity, okay? We might just be graphing between -1 and 3, for example. So you're welcome to just look at this part to start. This part we're familiar with, right? X is less than or equal to 3. Here's 3. It's less than or equal to 3. Okay? You can even draw the arrow if you want. Okay, that's the first half of the inequality. Take that second half. That second half is -1 is less than or equal to x. Another way to say this is x is greater than or equal to -1. Good? Okay. X is greater than or equal to -1. So I start at -1. And I'm going in this direction. Because of the equal sign, it's going to be a bracket. Okay? So those are the two halves of the compound inequality. Now you just put those two together, right? So here's my number line. I'm going to redo it. Here's -2, -1, 0, 1, 2, 3, right? So I had 3 with a bracket to -infinity. And then on the other side, I had -1 with a bracket to +infinity. And instead of infinity, now we just have a beginning and an end because the x is between the -1 and the 3. So we have -1, 3 in interval notation. It begins at -1 with a bracket. It ends at 3 with a bracket. X is between -2 and 2. X is greater than -2. X is less than 2. Okay. So again, you can split it into 2 if you want. X is greater than 2 and -2 is less than x, but I want to flip it around. So that's x is greater than -2. Good. So I move that there, flip the sign, and that's there, right? X is less than 2. Let's do that part. 2, and it's going in the less than direction. There was no equal sign. Yeah. So we're going to do parentheses. And then over here we have x is greater than -2. So I'm going to start at -2. There's no equal sign, so parentheses again. And what we have is -2 to 2. Here we have x is less than 1. So here's 1, and it's going in the less than direction. There's no equal sign, so it's does not include the 1. X is greater than, I'm just reading it backwards, right? X is greater than or equal to -3. Because of the equal sign, it's going to be a bracket. Good. So bracket at -3, 1, parentheses. Here they're asking us to solve the inequality and write the solution set in interval notation and graph the solution set. We have a plus 7 is less than 14. Good. Subtract 7. So just like you're solving those linear equations earlier, subtract 7 from both sides. A is, keep the sign the same, less than 7. I don't like that tiny graph. So here's 7, because I don't really care, right? 8, 6. That's a number line. Okay, A is less than 7. Less than means the arrow's going in this direction, away from 7. Less than means parentheses. And we're done. So we solved it, and then we graphed it. Now we say what it is in interval notation. Remember, interval notation is left to right. So from left to right, I am at -infinity to 7. Good. All right, here we've got f minus 6 is less than or equal to -13. Add 6. Add 6. F is less than or equal to -13 and 6. Those are two different signs, so we're subtracting. 13 minus 6 is 7, but the 13 is negative, so it would be a -7. F is less than or equal to -7. So usually it's an X, but this time it's an F. We're starting at -7. Here we have 6, 7, 8, but in the negative side of the number line, that's after 0, right? 0's over here, and then all of these numbers are negative. Now, -8's over here, and -6 is up here, so they kind of flip on the negative side. Good. F is less than or equal to -7. Less than or equal to, the arrow's going that way. Equal to means it's a bracket. Good. If I read it left to right, what do I see? I see -infinity to -7. Here we have 6z is greater than 5z minus 5. You need to solve for z first, okay? Here we solved for z by moving the +7 across. Here we solve for f by moving the -6 across. Here I need to combine the terms across the inequality symbol and then make sure that z is alone, the variable is alone. So we have 6z greater than 5z minus 5. I'm going to move that 5z by subtracting it. Because not only do I like my variable on this side, but I want my variable to be positive. So it does just become 1z, which is what we want. Z is greater than -5. Here's -5. In front of -5 is -4, and behind -5 is -6. Good. Z is greater than -5. Greater than is going in that direction. It does not include -5, so it's a parentheses. 3z minus 3 is greater than 2z minus 1. Subtract the 2z. Subtract the 2z. 3z minus 2z is just z minus 3 is greater than -1. Now move that -3 by adding 3. Z is greater than 2. Here's 2. To the left of 2 is 1. To the right of 2 is 3. Z is greater than 2. That means the arrow is going in the greater than direction, and it does not include 2. So it is a parentheses. I feel like I should have started this lesson with some number line stuff. Yeah. Oh, well. Graph the solution set of the inequality and write it in interval notation. So we have 7x is less than negative 37.8. Negative 37.8 divided by 7 is negative 5.4. X is less than negative 5.4. Again, you're welcome to put that into Desmos if you need some help visualizing where 5.4 would be between 5 and 4. Between negative 5 and negative 6, sorry. All right, so we've got X is less than negative 5.4. And then go ahead and zoom in. You can see it's between negative 5 and negative 6. And it's almost right in the middle between negative 5 and negative 6. So don't hesitate to use Desmos if you need it. If I was graphing it, here's negative 5. Here's negative 6. Somewhere right around here. It's less than, so it's going to go in that direction. There's no equal to, so it's parentheses. Good. 1/8 x is greater than or equal to 9. That's the same as saying 1x over 8 is greater than or equal to 9, or just saying x over 8 is greater than or equal to 9. Those are all the same exact thing, okay? What we're doing is we're dividing x by 8, right? You can also just say it's x divided by 8. They're all saying the same thing. Good. What do you need to do if it's being divided? You need to multiply both sides by 8. Now that cancels. I just have x greater than or equal to 9 times 8 is 72. X is greater than or equal to 72. Here's 72, we'll pretend. Greater than goes this way. And equal to means there is a bracket. So interval notation would be a bracket at 72 towards infinity. Infinity always gets the parentheses. Sorry, we didn't do interval notation here. Interval notation here, left to right, we've got negative infinity to negative 5.4. Doesn't include the negative 5.4, so it's parentheses. Negative x is less than negative 9. You're welcome to put this into Desmos and see what they give you, okay? Just don't forget the negatives. Negative x divided by negative 9. I don't want it to be negative, so I'm going to multiply it by negative 1. Anything I do to that side, I have to do to this side. Negative x times a negative 1 is just x is less than positive 9. Ooh, my goodness, I didn't even follow my own rule. It cannot be that one. It's x is greater than 9 because we multiplied by a negative, so we have to flip the sign. X is I don't know why I did it with a highlighter. X is greater than 9. That means it's going in that direction. Does not include the 9, so it's a parentheses. 20 is less than or equal to 4a. I'm going to divide both by 4 so I can get a alone. 20 divided by 4 is 5. However, 5 is less than or equal to a is not as easy for me as a is greater than or equal to 5. Make sure a is greater than or equal to 5. A is greater than or equal to 5. Make sure it reads the same. Good. A is greater than or equal to 5. So here's 5, we'll pretend. Greater than 5 is this way. Equal to means there's a bracket. Good. Here, they're just asking for interval notation, so you can skip the graphing if you want. You can graph it in Desmos if you want. It's easiest to get to interval notation via graphing, okay? So 24 minus 4x is less than or equal to negative 4. Let's move the 24 because I want the x alone, okay? You're also welcome to move the x because right now it's negative and you want it to be positive, okay? So that's perfectly valid. Now we have negative 4x, negative 24, minus 4. They're both negative, so they're being combined is a negative 28. Good. Divide by negative 4, divide by negative 4. X is, because we're dividing by a negative, we're flipping that sign, greater than or equal to negative 28 divided by negative 4. Feel free to put it in your calculator. I think it's 7, right? Good. So we flipped the sign because we did a negative. X is greater than or equal to 7. Here's 7. They didn't ask me to graph it, but that's the easiest way to get to interval notation for me. It's greater than, so it's going to go that way. And it's an equal sign. So it's going to include 7. It'll be a bracket. So interval notation will be 7 to infinity. Okay. Also, a way to check your answer would be I got x is greater than or equal to 7. You can take that solution and put it in Desmos. I thought I was hitting backspace. X is greater than or equal to 7. And put the original in. 24 minus 4x less than or equal to negative 4. Good. And you'll see that those are the same answer. So it's a kind of a way to check your answer. Good. Here we have x plus 7 is less than or equal to 4 times x minus 8. Good. Let's distribute the 4. So these are just the same steps you follow if this was that you would if this was an equal sign. X plus 7 less than or equal to 4x. 4 times 8, what is that? 32? 32. And now we just solve it like we did the one right below us. So I'm going to move the x. If you move it over here, you have to flip it. If you move it over here, you have to divide by a negative. So I'll move it over here. So remember when you see x, it's like saying it's 1x. 1 minus 4 is a negative 3x. Good. Now I have negative 3x plus 7 is less than or equal to negative 32. Subtract 7, subtract 7. Negative 3x is less than or equal to negative 39, right? Because 7 and 2 is 9, and they were both negatives. Good. Last step, divide by a negative 3. Divide by a negative 3. If I'm dividing by a negative, I have to flip that sign. So the less than or equal to becomes a greater than or equal to. Negative 39 divided by negative 3 is a 13. And then this is just x. X is greater than or equal to 13. Good. In interval notation, you can try it without the graph. Or you can just say 13 greater than or equal to. The equal to means it's a bracket. The greater than means it goes that way. So I'm going to call interval notation, bracket 13 to infinity. Good. All right, same thing here. Let's do it the other way. So I'll subtract 2x to get the x's together. Negative 5.5 is less than 3x plus 8. Moving the 8 over here. Subtract 8. You're combining them. 8 and 5 is 13, but they were both negative. So we have negative 13.5 is less than 3x. Now we're going to divide by 3. Divide by 3. Negative 13.5 divided by 3 is negative 4.5. Is less than x, but I would like to flip that around. X is greater than negative 4.5. Here's negative 4.5. It's greater than, and it's not equal to. So my interval notation is going to be parenthesis, negative 4.5 to infinity. Good. I'm going to skip that one. I want to skip that one. Feel free to skip this one. Here we need a common denominator. The common denominator is going to be 24. How do I get from 4 to 24? I do multiply by 6, right? Anything I do to the top of the fraction, I have to do to the bottom. So it's 3/4 is going to be multiplied by 6 plus 5/6. Wait, sorry. 4 times 6 is 24. I got confused. So 6 is going to get multiplied by 4 on the top and the bottom. Less than or equal to, this one doesn't change. Right? Uh, 6 times 3 is 18. 18 24ths plus 4 times 5 is 20 24ths less than or equal to x over 24. Now we can add those. This isn't the best way to do it. 38 24ths is less than or equal to x over 24. X is now being divided by 24. So we're going to multiply it by 24 to get x alone. Anything you do to this side, you have to do to this side. When I multiply them both by 24, they go away. And we get 38 is less than or equal to x, which means x is greater than or equal to 38. Here's 38. It's going in the greater than direction, and it is a bracket because it includes it. So we have including 38 to infinity. Compound inequalities, we want to isolate the variable. Oops, I'm sorry. The general goal when solving a compound inequality is to isolate the variable in the middle. Whatever step you do in the middle needs to be done to both sides of the inequality. So before we had an equal sign, or when you have an equal sign, you only have 2 sides, right? All of those other examples, you only had 2 sides. You had a left side and a right side. Now you have a left side, a right side, and a middle. And what you need to do is treat all 3 of those the way you treat the 2 sides of an equation. So solve the compound inequality. 8 is less than 2x, which is less than or equal to 12, okay? Graph the solution set and give interval notation. I want the x alone. Right now the x is being multiplied by 2, so I'm just going to divide it by 2, right? We know that. I do that to both sides now. Okay? 8 divided by 2 makes the left side 4. 2x divided by 2 makes the center x, and then 12 divided by 2 makes the right side 6. We're done. Okay, now it's just a matter of graphing that. Here's 4, and here's 6. X is less than or equal to 6. Equal to means it's a bracket, less than means it goes this way. And here we have x is greater than 4. I'm going to rewrite it. 4 is less than x, or x is greater than 4. There is no equal sign, so it's parentheses that way. Okay, so my final answer is it begins at 4 and does not include 4. It ends in 6 and does include 6. A better looking graph would be. Okay. Parentheses, line, bracket. Good. 17 is less than or equal to 4t plus 1, which is less than or equal to 21. Subtract 1 because I want, sorry, I'm going too fast. I want the t in the middle to be alone. Okay? What's happening to it is being multiplied by 4 and 1 is being added to it, so I'm going to subtract 1 from it. Anything I do to the middle, I have to do to both the left and the right. Good. That cancels. 17 minus 1 is 16. 21 minus 1 is 20. Okay. Now t is being multiplied by 4. I'm going to divide it by 4. 16 divided by 4 is 4. Now we have t is less than or equal to 5 and t is greater than or equal to 4. Here's the number 4, and here's the number 5. Good. T is less than or equal to 5. It means it gets a bracket, and it goes in the less than direction. T is greater than or equal to 4, means it gets a bracket, and it goes in the right-hand direction, positive direction, okay? So my interval notation would be bracket 4, comma, 5, close the bracket. 28, now I have 4 is less than or equal to 3t minus 2, which is less than or equal to 13. I want t alone. Right now, t is being multiplied by 3, and then 2 is being subtracted from it, okay? Add 2. If I did it to the middle, I have to do it to the left side and to the right side. Now I have 3t. I have 13 plus 12. 2 is 15. 4 plus 2 is 6. Okay. Now what's happening? The t is being multiplied by 3, so I need to divide by 3. 6 divided by 3 gives me 2. 3t divided by 3 just leaves me with t, and then 15 divided by 3 leaves me with 5, okay? I'm going between 2 and 5, okay? T is less than or equal to 5. The equal to means it's a bracket, and the less than means it's going to the left or in the negative direction. Good? T is greater than or equal to 2. Equal to or greater than. Okay? Interval notation, bracket 2, comma, 5, close the bracket. All right, we've got 2 more examples if you need them. 11 is less than or equal to 5 halves x plus 6, which is less than 31. Notice the 2 different signs. This one's less than or equal to, and this one's equal to. Also, please notice 5 halves x. So 5 halves x is the same as 5x divided by 2, or the same as writing it this way. Okay, just like that. What was that other one? What was it? 1/8. I like that one. 1/8 x is the same as 1x over 8 is the same as x over 8, which is the same as x divided by 8. Okay, so these are all the exact same value, and what we're saying is x is being divided by 8, or x is being multiplied by 1 and then divided by 8. Okay, here we're saying x is being multiplied by 5 and then divided by 2. All right, 11 is less than or equal to 5x times 5 divided by 2 plus 6, which is less than 31. Okay? I should probably just write it down. X times 5 divided by 2. What's the first thing we're going to do? The first thing we're going to do is subtract 6. $11 minus 6. 5, right? It's alarming that I didn't know that off the top of my head. 5 is less than or equal to 5 halves x, or x times 5 divided by 2, which is less than 31. Okay, so remember, x is being multiplied by 5 and then divided by 2. Multiplied and then divided. So the next step is get rid of this, divide by 2. How do you cancel out being divided by 2? You multiply by 2. Multiply by 2, multiply by 2. Is that okay? That will cancel the bottom of the fraction, and we'll just have 5x there. 5 times 2 is 10. Signs are the same because that wasn't a negative we were multiplying by. Now I just have 5x. 31 times 2 is 62. Good. Oh, well, I didn't even subtract 6. I just wrote 31. What is 31 minus 6? 25? And so 25 times 2 is 50. All right, so we have 10 is less than or equal to 5x, which is less than 50. Good. Last step, divide by 5. Ten divided by 5 is 2, is less than or equal to x, which is less than 50. Nope, 50 divided by 5 is 10. Guys, better stop this video after the next question. So again, we have 2 is less than or equal to x, which is less than 10. Good. Here's my 2. Here's my 10. X is less than 10. Does not include 10, so it gets a parentheses. Goes that way. X is greater than or equal to 2. Greater than goes to the right, and equal to 2 means the 2 gets a bracket. So interval notation is going to be bracket 2, 10, parentheses. All right. Last one. Looks a lot like this one, but they're decimals. Don't worry about them being decimals. It's the same rule applying, okay? 0.5 is less than 0.4x, or 4x times 0.4 minus 0.6, which is less than 1.3. What do I want to do? I want x alone. So 0.6 is being subtracted. I'm going to add 6. Anything I do to the middle, I have to do to both sides. 0.5 and 0.6, feel free to use your calculator. We're not going to go into detail on decimals. It's 1.1. 5 and 6 is 11, but you keep the decimal spot. Keep that sign the same. 0.4x. Those cancel. Those become 0. And then 1.3 plus 0.6. And again, you can think about 13 plus 6 is 19. And then keeping the decimal spot, keeping the decimal placeholder. But you don't have to. I would suggest using your calculator. Now, x is being multiplied by 0.4. How do you do the opposite or get rid of 0.4 multiplication? Divide by 0.4. No x, just copy. So I'm dividing by 0.4. And you'll notice that here I didn't put the 0 in front of the decimal, and here I did. It does not matter. 1.3 plus 0.6 is 1.9. 1.3 plus 0.6 is 1.9. Okay. Kind of like saying 15 is 15 and 15.0 is also 15. Okay. All right. 1.1 divided by 0.4. 2.75. Keep the sign the same. That is going to cancel and leave my x alone. Keep that sign the same. 1.9 divided by 0.4 is 4.75. Good. So my final answer is that x is less than 4.75. X is greater than 2.75. So any number between 2.75 and 4.75 is a solution for this inequality. Right? X is greater than 2.75. Oops. Look at me. That's a parenthesis. X is less than 4.75. So interval notation will be parentheses, 2.75, comma, 4.75, close the parentheses. All right, guys, that is all I've got. Thank you for watching.